STWA and Temple University have developed a technology that reduces viscosity of crude oil and diesel fuel. This technology could lead to more efficient oil pipelines and wells. That product we call applied oil technology. Additionally, this technology could lead to improved fuel economy and reduced emissions. We call that technology the ELEKTRA. Research done at Temple University has found that the application of an electric field to crude oil and diesel fuel reduces viscosity. For example, API 11 crude oil normally has a viscosity of 112,000 centipos. Experiments at Temple University have found that once the electric field from our ELEKTRA technology is applied, the viscosity of the API 11 crude oil decreases to 92,000 centipos, a 17% reduction in viscosity. The ELEKTRA technology works by passing the crude oil or diesel fuel through an electric field created by electricity applied to a series of copper meshes. In the following test, you will see a voltage of 45,800 volts at 6 microamps applied to the copper meshes. Then crude oil or diesel fuel with a lower viscosity will flow out of the ELEKTRA. So how does it work? What is reducing the viscosity of the oil? Crude oil and diesel are fluids with dissolved particulate matter in them. Dissolved particles, when rubbing together, create drag within the fluid, increasing the overall viscosity and making it more difficult to pump and spray the fluid into droplets. We apply an electric field in the fluid flow, forcing particles to align in the direction of the electric field. When this happens, the particulate matter's natural tendency to combine into clusters is enhanced, enabling the total surface area per unit of dissolved particulate matter to decrease, giving more volume within the fluid for the dissolved particles to move, reducing their interparticulate friction, thereby reducing viscosity. We are in the process of developing ELEKTRA products that will reduce the viscosity of the diesel fuel so that a fuel injector will send a finer mist into an engine. This finer fuel mist will burn more efficiently than existing technologies, improving fuel economy and reducing emissions. We are also in the process of developing products that will reduce the viscosity of crude oil in pipelines so that the cost of oil transportation can be reduced. We call these products Applied Oil Technology, or AOT for short. Next, you're going to see a video of the ELEKTRA technology reducing the viscosity of crude oil in the lab at Temple University. We are going to show two passes through the ELEKTRA system. In the first pass, we're going to measure the difference in flow between the left and right side of the apparatus with no voltage applied. In the second pass, we will turn the ELEKTRA on by applying voltage, and we're going to measure the difference in flow between the left and right side of the apparatus with the ELEKTRA turned on. In this demonstration, you will see the ELEKTRA improve the flow of crude oil by 12.9%. The apparatus you will see has a reservoir on the top containing crude oil. The reservoir feeds into a Y-shaped tube that splits the flow evenly into left and right. The oil flows through an ELEKTRA on both the left and right sides. And at the bottom of the apparatus, the oil flows into beakers. By measuring the difference in the weight of the oil in the beakers at the end of the experiment, we can determine how much faster the oil flowed. Here is the reservoir on top of the apparatus that contains the crude oil. This is the Y-shaped glass tube that splits the oil flow into left and right, flowing into an ELEKTRA on each side. In the beginning of this pass, we have two empty beakers, beaker A and beaker B. We are going to measure the weight of the empty beakers. The mass of empty beaker A is 56.1 grams. And the mass of empty beaker B is 57.5 grams, almost the same mass. Now that we know the difference in the weight between the two beakers, we're going to run oil through the apparatus for 9 minutes and measure any difference in the flow between the two sides of the apparatus with the ELEKTRA turned off and no voltage applied. Here you see we are ready to start the stopwatch and start filling the beakers. Now we fast forward 1 minute into this first pass and the beakers are about 10% full. Moving forward, and here at 4 minutes the beakers are about 40% full. And at 8 minutes the beakers are about 90% full. And now at 9 minutes we will stop the flow into the beakers. Now we're going to measure the weight of the beakers. So, the mass of beaker A is 127.4 grams. And the mass of beaker B is 131.2 grams. So with no voltage applied, beaker A weighed 127.4 grams and beaker B weighed 131.2 grams with oil. So subtracting the empty weight of the beakers, we get beaker A having 71.2 grams of oil and beaker B having 74.7 grams of oil, a difference of 4.8%. So when we run the next pass with the ELEKTRA turned on, we know that the right side of the apparatus flows 4.8% faster just due to the differences in the tubing. Now we will turn the ELEKTRA on and run crude oil through the apparatus for 10 minutes, and then measure the difference in the oil in the two beakers. Now for the second pass, we will apply 45,000 volts at 6 microamps. 6 microamps is such a small amount of current that it will not ignite crude oil or diesel fuel. In the beginning of the second pass, we have two empty beakers, beaker E and beaker F. We're going to measure the weight of the empty beakers first. And the mass of empty beaker E is 57.9 grams. And the mass of empty beaker F is 58.4 grams, almost the same mass. Here you see we are ready to start the stopwatch and start filling the beakers. Now we fast forward a minute into this first pass and they're about 10% full. Moving forward here at 4 minutes, we're about 40% full. Here you can clearly see that the left side with the ELEKTRA turned on has more oil. Now at 10 minutes, we will stop the flow into the beakers. Again, you can clearly see that beaker E on the left side has more oil than beaker F on the right side. Now we are going to measure the weight of the beakers. The mass of beaker E is 135.4 grams and the mass of beaker F is 130.2 grams. So with voltage applied and the ELEKTRA turned on, beaker E weighed 135.4 grams and beaker F weighed 130.2 grams with oil. Subtracting the empty weight of the beakers, we get beaker E having 77.4 grams of oil and beaker F having 71.7 grams of oil. The left side with ELEKTRA has 7.9% more oil. Pass 1 showed that without the ELEKTRA technology, the right side flows 4.9% faster. Pass 2 showed that with the ELEKTRA technology, the left side flows 7.9% faster. So to find the true overall improvement, we add 4.9% and 7.9% together. This proves that in the experiment, the ELEKTRA increased the flow of crude oil by 12.9%. We are in the process of developing products with this technology. There are over 200,000 miles of oil pipelines in the United States alone. We have shown you that our technology has increased the flow of API 11 crude oil by 12.9%. Other tests with other grades of oil have resulted in improvements as great as 30%. We are developing products to improve the flow of crude oil, which could reduce transportation and harvesting costs. Possibly even more compelling is the fact that modern engines use fuel injectors which atomize fuel into small droplets. STWA and Temple University tested the ELEKTRA technology on a diesel fuel injector. The tests found that the number of droplets with a diameter less than 40 micrometers increased dramatically. The tests found that the number of the smallest droplets, less than 5 micrometers, tripled. We are working on developing technology so that fuel injectors can be made to produce 3 times as many small fuel droplets. Smaller fuel droplets burn more efficiently, leaving less byproducts. Burning smaller fuel droplets could significantly reduce diesel emissions and save millions or even billions in diesel fuel costs. Complete set of technical papers from Temple University are available on our website at www.stwa.com. STWA is traded over the counter on the OTC bulletin board under the symbol ZERO. For more information, please call STWA at 1-877-USA-STWA.